Good morning, students. Jai Swaminarayan. Today we are going to complete miscellaneous exercise 7. Now we have done, students, first 6 sums. Today we are going to start 7th sum. In an examination, a question paper consists of 12 questions divided into 2 parts, part 1 and part 2. Okay, students, exercise 7, answer 7. Question paper total consists of 12 questions divided into 2 parts, part 1 and part 2. Part 1 has 5 questions and part 2, students, has 7 questions. The students is required to attend the questions, 8 questions in all, selecting at least 3 from each part. In how many ways the selection can be done? At least 3 questions from each part. A student is to select at least 3 questions from each part. So here also minimum 3 and here also minimum 3, and total of 8 questions. Total of 8 questions are to be answered out of 12. This is what is the constraint. So once again, students, this is a sum of restricted combination. Why combination? Because it is selection. So if a student selects 3 questions from part 1, he has to select 5 questions from part 2 to make a total of 8. 4 from each and 5 3 respectively. These are the possible choices or options available for the student. These are the possible choices or options available for the student. So, number of ways in which a student can attempt 8 questions is equal to. Now, in the ordered pair, first element is for part 1 and second element is for part 2. So, 3 5 or 4 4 or 5 3. Students, I have shown this in the form of an ordered pair. So students, this is the possibilities for attempting at least 3 questions from each part. Okay, students. So now we do this combination. So from part 1 3 out of 5. So 5 C 3, and from part 2 7. So sorry, 5 out of 7 5. So 7 C 5. Or plus 4 from each. So from part 1 out of 5 will be 4, and from part 2 out of 7 will be 4. Or plus from part 1 all 5. So 5 C 5, and from 7 3. So simplifying this, we get 5 factorial upon 3 factorial into 2 factorial factorial, 7 factorial upon 5 factorial into 2, 5c4 will be 5 into 7 factorial upon 4 factorial into 3, 5c5 is 1 into 7 factorial upon 3 factorial into 4 factorial. So simplifying this, one's final answer comes out to be 420. Already you can say odd figures means 420 ways in which the student can attempt at least 3 questions from each part. So all these questions, students, all the sums of exercise 7 has been asked in competitive examination. All the questions of exercise 7, students, are affiliated to competitive examination. That is why I was keen in discussing this type of questions. Okay, students, so you have to be very cautious, you have to be very attentive. If it is required to sit 5 men and 4 women in a row, so that the women occupy even places, in how many ways such arrangements are possible? Students, all of you are by the time well versed with the concepts and or theorem. You know arrangement implies permutation, selection or draw implies combination. By this time, students, you must be well versed in this concepts. But once again, I am revising this master keys. Arrangement indicates the use of permutation. This we have to perfectly understand and monitor. Whereas selection or draw indicates the use of combination. So I have been repeatedly reiterating this. I have been repeatedly, students, reiterating this. Then for and we go for multiplication, for or we go for addition. So this is called and or theorem. This is called and or theorem. So never forget this in permutation and combination, students. These concepts are the most important one. Now it is required to sit 5 men and 4 women in a row such that women occupies even places. Okay. Answer 9. 5 men and 4 women. So total we are given 9 persons. Now women occupy even places. So first of all, I draw 9 places. 1, 2, 3, 4, 5, 6, even places. So second, fourth, sixth and eighth. This line diagram or this simple box diagram will help us to understand, students, how the arrangements can be possible. So, pay attention, students. It is conditional permutation. Secant means arrangement, and arrangement indicates the application of concept of permutation. Now, first of all, I arrange elements. 4 elements can be arranged in 4p4 because we have 4 places and 4 women, and that is 4 factorial ways. So 5 men in 5 odd places. Check how many odd places? 1, 2, 3, 4, 5, and 5 men. So 5 and 5, that is 5 factorials. So total ways of arrangement as per given condition will be 4 factorial into 5 factorial 24 into 120. If I multiply this, we get 2880. 2880 ways. This is, students, our final answer. So these are the sums of conditional permutation. Previous was the sum of conditional combination, students, and you have to be very perfect in understanding all the basic, students. The more you understand, students, the more you enjoy. This is a concept which is very useful in day-to-day life. So, students, you have to be very careful, you have to be very attentive for doing the sums of permutation and combination. Now, sum number 10. Our next question is sum number 10. From a class of 25 students, 10 are to be chosen for an excursion party. Okay. 3 students who decide that either all of them will join or none of them will join. In how many ways can the excursion party be chosen? Chosen means selection. Selection means, you can say, combination. These students we have to perfectly understand. Now we have a class of 25 students. Let us divide this into 2. 3 specific students and 22 others. Students, we have divided the class of 25 into 2. Data collection. The same students I was reiterating in exercise 7.4. If you remember, students, data collection becomes a very important aspect of the sum. Now we have to select a group of 10 students. So out of 25, we have to select a group of 10 students. Condition is that a group of 3 is always included and a group of 3 is not included. Say 3 friends A, B and C decide that either all 3 will attend the party or none of them. So total ways of selecting selecting 10 students according to given condition. First case or second. So all these 3 are there, then they can be selected in only one. Then this 3 must be included. So the remaining 7 from 22. So 22 C7. None of this. Okay, fair. That also can be 1. So the remaining 10, all 10 in fact, from 22. This is the total possibility. Either we select that group of all 3 specific or none of them. Now these 3 students out of given 3 can be selected one way, and this is 22 factorial upon 7 factorial into 15 or means addition. They can be rejected in one way, 22 factorial upon 10 factorial into 12 factorial. Simplifying, the answer is 8,17,190. Addition of this is 8,17,190 ways we can select 10 students. So it is quite, you can say, a large number. Now students, the last sum of the chapter. Now students, the last sum of the chapter. Now here we have to first understand what is the given data and correspondingly students we apply. In how many ways can the letters of the word assassination be arranged so that all S are together? Arrangement means assassination. Okay, students, this is the given word assassination. Now, first of all, we count total letters 3 and 3, 6 and 3, 9 and 4, 13. So, total letters of this word are 13. A is repeated 3 times. S is repeated 4 times. I is repeated 2 times. N is repeated 2 times. So 7 and 4, 11. Then T and O once. Okay. Now we have to use permutation, and that 2 permutations of identical objects or permutation with repetition. So grouping 4s as 1, 1, 2, 3, 4. Remaining A, I, N, A, E, I, O, N. So, this is how the condition of the sum is. Now, in permutation, I have explained this perfectly. The things which are to be kept together, we group them as one. So, grouping 4s as one letter, remaining how many? 9. So 9 plus 1, 10 letters can be written in 10 factorial upon 3 factorial into 2 into 2. Why? Because in this 9, A is repeated thrice, I is repeated twice, and N is repeated twice. Now internal arrangement of group. In group we have 4s, so 4 factorial, but all these are repeated, so divided by 4 factorial. So, this is very simple, students. This is very interesting, and this is now very easy also. Simplifying this, the number comes out to be 1,51,200. So, total ways in which 13 letters can be arranged with 4s together is equal to 1,51,200. A huge figure, students. A huge figure. So, this completes our entire chapter 7 along with exercise 7. Okay. Now, students, we revise for 5-7 minutes all the basics of the chapter once again, so that you people are very thorough with this concept. Now, pay attention, students. Our first approach to the chapter was fundamental principle of counting. This was the first concept in the chapter. Suppose an event can occur in n ways, correspondingly after that the second event can occur in n ways, and after that the third event can occur in p ways. Then the total ways in which all the 3 events can occur in order are n into n into p. So this is the fundamental principle of counting, students, for 3 events. I repeat, suppose an event can occur in n ways, after that the second event can occur in n ways, and after that the third event can occur in p ways. Then the total ways in which all the 3 events can occur in order are n to n into p. This is the fundamental principle of counting for 3 events. It can be generalized to any number of events, 12 events, 20 events, 40 events, and even 100 events. Then, students, we have the concept of permutation. And before that, let us go for factorial notation. What is factorial? the product of first n natural numbers. The product of first n natural numbers is defined as n factorial. For example, 5 factorial means the product of first 5 natural numbers. And if I multiply first 5 natural numbers, students, then we will get the answer as 120. So x factorial, where x must be necessarily a natural number, is the product of first x natural numbers, and an exception here is, as an exception, we have 0 factorial is 1. 0 is not a natural number. As an exception, students, we have 0 factorial is equal to 1. The next important concept was permutation. What is the definition of permutation? The total ordered arrangements of R items or things out of given total n items are called permutations of R things, items or objects, whatever it is given. I repeat, the total ordered arrangements of R things out of given n things are called permutations of R things, which is denoted by NPR, and the formula is n factorial upon n minus r factorial, and second formula is n minus 1 n minus 2 up to n minus r plus 1. So students, one has to be very careful while understanding permutation. Once again, what is permutation? The total ordered arrangements of R items out of given n items is called permutations of R items, denoted by NPR. The word order is very, very important. Then permutations with identical objects. Then permutations with identical objects. So given are n items out of which P are of one type, Q are of second type, and R are of third type. Then total arrangements of this n things can be done in n factorial divided by p factorial into q factorial into r factorial. We divide by the total number of identical objects. So this was the concept of permutations with identical objects. Now define combination. The total random selections of R things, the total random selections of R things out of given n things is called combination of R things, denoted by NCR, and the formula is n factorial upon R factorial into n minus r factorial. additions of R things out of given N things are called combinations of R things, denoted by NCR, and the formula is NCR is equal to N factorial upon R factorial into N minus R factorial. Order not important. Basic formulas of combination: NC0 is equal to NCN is equal to 1. NPR is equal to NCR into R factorial. NC1 is equal to N. If NCX is equal to NCY, then X is equal to Y, or N is equal to X plus Y. And last but not the least, NCR plus NCR minus 1 will be N plus 1 CR. These are all basic properties or formulas involved in combination. So hereby we complete, students, our most important chapter of 11th standard after trigonometry, and that is permutation and combination. So I request you to do these sums, whether these are there in the syllabus or not is a secondary thing. Students, don't only study from syllabus point of view. Knowledge is important, concepts is important, fundamentals are even more important. So we conclude the exercise, we conclude the lecture, and we conclude the chapter. Keywords you know: arrangement indicates application of permutation, selection or draw indicates application of combination, for and we multiply, for or we add. This much, students, you have to perfectly remember and memorize. Do not forget and or theorem. Thank you, students. Study well. See you soon for the next chapter.